It's George Tyndall, and I'm back again. And I'm here to try and explain to some people out there so they can understand. Now, I'll be using my findings and their findings and their science, the experts out there. This is what I do. I put what I find and I combine it with what the experts know. Okay, but you got to be searching in the right place and you got to be looking for the right things to be able to understand this. But this will help people understand a little bit more. Now, the history of metals heating and cooling cycles can influence its melting point. Okay, repeated heating and cooling can change the metal's microstructure, potentially leading to a variation in its melting point over time. Now, this has to do with what I said about meteors roasting in the mesosphere. But this also applies to being out there in space and being exposed to what we call space weathering. Now, you have to look it up to understand what space weathering is. It has to do with rocks out there being able to get cold and then get hot, and then get cold and then get hot. And I'll explain how that happens. Okay. Metals can lose magnetism when heated and cooled repeatedly. Okay, so if you have your rock and it reaches a certain temperature and then it drops down and then it goes back up and it drops down, which this does happen. And I'll explain this. Okay. Mercury and Venus both have an 800 degree Fahrenheit temperature in the day and a nighttime temperature of minus 290 degrees Fahrenheit. Okay, you're talking about heating, staying hot during the daytime, and then a rapid cooling at nighttime. So, and I'm going to go along and I'm going to explain this. Okay, how I know that the rocks from the other planets are already here. Okay. Now, why people can't see what they're expecting to see is because when a metal oxadie is repeatedly heated and cooled, it can experience several changes depending on the specific temperature and the metal involved. Okay, so you can change the oxadie, including potential structural degradation, increased surface area changes in oxidation state, and in extreme cases, decomposition into the metal and oxygen gas. Okay. However, the exact effects will vary based on specific oxidie and heating and cooling cycle used. And metal oxides can change in color. But, it is what it is where we're going into here. Now, I'm reading everything that I looked up. Okay, metal oxides typically form solid crystalline structure. They can exhibit various surface textures, different textures. The oxidie on a meteor could exhibit a texture that you're not used to. That one that you're trained and you're expecting to find is the rough texture. And that depends on the formation process, how the fusion crust is formed. For example, some metal oxides can form a thin, flexible film that are transparent and conductive. They can have unique characteristics. And fusion crust is an oxadie. Okay? Now, if anybody's been able to follow so far, I'm going to go to the rocks and I'm going to explain this. Now, if fusion crust is able to change and it's able to be different, that's why if you're just looking for it one way, like this, and this is what everybody looks for, the one type of fusion crust is this rough kind. That's what everybody looks for. But, and I'm going to show you all these. All of these are from space. And I know people aren't going to want to believe it, but I'm going to show them. Okay? This is metal too. But it's different. It's smoother. Different temperatures, different pressures. This is metal that is on the outside. They look different. They're not all the same and they look different. Same way with this one. This is metal. But why the oxadie looks the way it does on it is because of the way the temperatures and the pressures and everything. This is a solid piece of metal, okay? But it still maintains a rock-like form. But this is metal under this. Whether people want to believe it or not. The fusion crust on here is different. Same with this one. Same with this. This film is a thin layer on the meteorite. The orangish color is the iron underneath. Underneath. It's transparent. The fusion crust on this is transparent. And it's a black fusion crust, but when it's wet, you can see the transparency. Now, getting back to Mercury and Venus. Okay. We're going to take this one. This gray colored rock right here, this gray one right here, is from Mercury. And I'm going to tell you how and why it is different and it doesn't look like what you're expecting to see. Now, say this one stayed on Mercury for 1 billion years and it was blown off into space. Okay, you've got 1 billion years. You've got 1 billion years where this rock right here, in the daytime, 800 degrees. In the nighttime, negative 290 degrees Fahrenheit. For 1 billion years, you're heating, cooling, heating, cooling, heating, cooling, heating, cooling. And I'm just saying 1 billion years, not 4.5, 1 billion. Okay, after 1 billion years, this gets blasted off the planet. It's into space. This thing is altered so much that the outside, the fusion crust, is going to be gray. Because it's been altered that so much. And I could cut this open and look at a section under a microscope and I would know. I've been able to do it with several other rocks. Rocks like that on Mercury are altered, and the planet is extremely, extremely hard. For as long as it's been out there, it's been exposed to the temperatures, the radiation from the sun, the solar flares and everything, getting bombarded with radiation and everything. That planet is hard as hell. Now, the fusion crust is a rough gray on the rock, but why this is the way it is because when it came through the atmosphere, the melting point had been altered in this to real high. That's why it came through the atmosphere and left virtually no black on it at all. But it would come out red hot. And that's what I tried to explain to people. Okay? Out in space, and it even says that asteroids are exposed, and rocks that float around out there, they're exposed to what they call space weathering, which is increases and decreases in temperatures. And that alters rocks. Now, I can't be really any more clearer. Now, why it's magnetically weak, and I got to bring the magnet up like that, but the magnet pulls to it, is because when you heat and cool and heat and cool and heat and cool, when you do it, and you do it rapidly or slowly or whatever, it alters everything. And this is one reason right here why people can't find space rocks. But by me taking my rocks and putting it with the science, I can figure this out. But I'm telling you. And that's why you see no rocks on Mercury. It's because the majority of them are here on Earth already. But no, it's impossible. Well, it isn't impossible. And I'm telling you like it is what it is. And I'm going to call that good.